Greetings, we are Group 13 and we are doing Project 4, which is about hand-eye calibration for DoBot's robots. In this project, we aim to find a means to establish the spatial relationship between a camera and a robot ends effector.
This phase calculates the camera's pose relative to the robot using the eye-to-hand approach, where the camera is fixed while observing the robot's movements. By tracking a calibration grid on the end effector, we determine the transformation between the camera and the robot's base, providing a reference for the vision-based control. The process follows finding the A transform, TBE, which represents the position and orientation of the robot's end effector relative to its base, which we calculate using forward kinematics. This gives us the robot's pose at each movement. The B transform, TCP, is the position of the camera relative to the pattern on the end effector, determined through pattern recognition. The X transform, TBC, is the unknown transform between the base and the camera, which we are trying to find. To calculate X, we use multiple sets of the transforms A and B between different positions, and plug them into the equation AX equals XB. We then average these X transforms to get a more accurate transformation between the base and the camera.
The second phase of the system is visual servoing. Here, the camera provides real-time feedback on the robot's movements to guide its end effector to the desired pose. The visual servoing process is a closed-loop control system that adjusts the robot's actions based on the camera's input. It involves error calculation, comparing the desired position of the pattern with its actual position. Velocity control, calculating the required velocity using v equals negative L inverse E, where L is the image Jacobian and E is the error, then telling this to the robot. Resolved motion rate control, smoothing and avoiding singularities using RMRC based on the given equation.
This project was created using MATLAB with pattern recognition and Peter Koch's robotics toolbox. A Logitech Brio was used as an RGBD sensor for this project. However, its eye depth sensing capability was ultimately not required for our system. Testing revealed performance issues under varying lighting, and this was addressed by optimizing our pattern detection algorithm. Initial issues were faced with connecting to the DoBot using the Raspberry Pi, but this was eventually resolved with further testing.